Hello friends, you're welcome to my YouTube channel. In this video, we have a very interesting aspect that I want to cover, which is what? Differentiation from first principle. So as you can see, it says find the derivative of the following with respect to x using the first principle. So these are the questions we are going to be solving in this video. Now, when they say from first principle, there's a way it is done. It is not the general differentiation rule. This is how you do it. You have to do change in y over change in x. So if I pick this first case now, where you have x, I can say let y be equal to x. Now, if you want to differentiate using the first principle, what you have here is delta y, or change in y over change in x. So for you to get this delta y, I'll be using delta and change interchangeably. So if I say let y be equal to x, and I'm trying to get this change in y with respect to what? Change in x. I'm going to add change in y to y, and I'll add change in x to x. That's what I'll do first. So I'll say y plus the change in y is equal to then x plus what? Change in x. Since I'm trying to get change in y with respect to change in x, look at this now. What do I need to remove from here so that I will have change in y? Of course, I'll take y away from here. So I will now have this. If I transpose y to the right hand side, I'm going to have minus y. Okay. Now change in y is now equal to x plus change in x minus y is something. What is y? Y is equal to x. So I'm going to write x here. I'm replacing y. I'm putting x in place of y. So minus x plus x is 0. So what I have now is change in y is equal to what? Change in x. But I'm trying to get to this point here where we have change in y with respect to what? Change in x. So I will divide both sides by what? Change in x. So change in x and then change in x. So this cancels this, you have 1. And you have that change in y with respect to change in x is equal to 1. But if you need to get dy dx, I will now set the limit of dx as it tends to 0. So I will say therefore dy dx will be equal to the limit as change in x tends to 0. Then we're basically replacing change in x with 0. If you have it here, but we don't have it here, we still have 1. So the final answer will just be that therefore dy dx is equal to 1. This is how it's done. It's very, very easy. This is how you differentiate from first principles. So let's look at the second one, which is what? X squared. Again, I'm going to say let y be equal to x squared. So if I come here, I'm going to write that let y be equal to x squared. Look at what we did before. We added change in y to y and change in x to x. So I'm going to start by doing that. So y plus what? Change in y then is equal to what? X plus change in x. See, there's a squared here. So this square is affecting x and the change added to x. So I'll wrap this in a bracket and square it. Are you with me? So, you know, I told you before that this y we have to leave because we're trying to get to change in y with respect to change in x. So change in y will be equal to x plus change in x all squared minus y. And what is y? Y is what? X squared. So I'll remove y and replace it with what? X squared. So that will be change in y is equal to x plus change in x all squared minus what? X squared. But we have to expand this. So change in y will be equal to, this is x plus change in x. So you are multiplying it by itself because of the squared. So plus change in x minus x squared, okay? So what's x times x? This is x squared. X times change in x is what? X change in x plus change in x times x is x change in x. And change in x times change in x is what? Change in x squared. Then we have minus x squared. So we're going to cancel this one. See, minus x squared cancels what? X squared. What do we have left? We have x change in x plus x change in x will be what? 2x change in x then plus what? Change in x squared. Remember, this is the change in y. We're trying to get to what? What's the next thing now? you divide both sides by what? Change in x. So here change in x, and then here to change in x. So you have change in y over change in x is equal to, we're using this to divide this and this. So I have 2x change in x over change in x plus change in x squared over change in x. This cancels this, and change in x cancels one of this. You have change in x. So change in y over change in x is equal to 2x, then plus what? Change in x. Are you with me? Now I want to bring the limit as change in x tends to 0. So I'll write dy dx is now equal to the limit as change in x tends to 0. So you come here and replace change in x with what? 0. So plus 0. Therefore, we can say that dy dx is equal to, we've already replaced it with 0, so we just have 2x. 2x. So this is what we get when we differentiate this with respect to x. Let's look at the last one, which is what? 3x squared plus 2x. I'm going to take this off and do the last one. So for the third one, I'll say let y be equal to what? 3x squared plus 2x. Again, as usual, I'm going to add change in y to y and add change in x to x. So y plus change in y is equal to 3. This is 3x squared. So I'll write x because we're adding change in x to x. So in bracket x plus change in x, there's a square here, so you have to put it there. Then plus 2x. So that will be what? X plus change in x. All right? What's the next thing? We remove y from here. We're getting to change in y over change in x. So if I remove y from here, I will have change in y is equal to 3 bracket x plus change in x all squared, then plus 2 bracket x plus change in x. If you move y over, I have this. But let me remove this y and replace it with what y is set to. Y is what? 3x squared plus 2x. Very good. So it's time to expand this now, and let's get our answer. But before I use 3 to multiply this, I have to expand this first. So 3 bracket, again from binomial expansion, this will be what? X squared. I did it before. Plus what? 2x change in x, then plus what? Change in x squared. All right? In bracket, then plus, let's expand this. 2 times x is 2x. 2 times change in x is what? 2 change in x. Then this one becomes minus 3x squared and what? Minus 2x. Be careful with this. Now let's expand this. So change in y will be equal to 3 times x squared is 3x squared. 3 times this is what? Plus 6x change in x. Then 3 times this is what? Plus 3 change in x squared. Then you have plus 2x plus 2 change in x minus 3x squared minus 2x. Let's cancel out. So 2x cancels 2x. 2x cancels minus 2x. Minus 3x squared cancels 3x squared. So I now have change in y is equal to 6x change in x, then plus 3 change in x squared, and what's this? Plus 2 change in x. What's the next thing now? I'll divide both sides by what? Change in x. So the next thing I'll do now is to divide both sides by what? Change in x. So change in x here, 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 and then here. Now this cancels this. This cancels this. You have change in x. This cancels this. So what do we have? We have change in y over change in x is equal to, this is 6x plus 3 change in x, then plus 2. So let me bring it here. Let me just rewrite it here. Change in y over change in x is equal to 6x plus 3 change in x plus 2. What's the next thing? That we bring in the limit. So I'm going to say dy dx is equal to the limit as change in x tends to 0. So we're going to replace change in x with what? 0. So I have 6x plus 3 dx will change to what? 0, then plus 2. And then dy dx is now equal to, this is 6x, 3 times 0 is 0, then plus 2. So this is the result that we get when we differentiate y is equal to 3x squared plus 2x with respect to x. I hope you enjoyed this video. If you did, kindly subscribe, share this video with your friends and family, and don't forget to follow for more content like this. I'll see you in the next video. It's bye for now.